We're turning a corner for project 2. We're going to talk about surfaces, and I have something quick that I've drawn up in Illustrator, and I'll be PDFing this and posting it for you guys to use as a reference. But I thought I'd just talk about this really quickly. Just address this towards the or in our first meeting, or our meeting on Monday. But just a quick rehash, right? So, in project 1, we're talking about curves. And so we were talking about evaluating a curve at a t parameter. And so we're talking about the sort of topological space of a curve and how it's a sort of, you can think of it as a road with a street address that counts down or counts up depending on which direction you're going. The t parameter is that address that we're talking about, and we usually typically reparameterize the curve so that starting address is 0 and the end address is 1. Right? So if we evaluate a curve at a t parameter, let's say 0.5, then what it does is it places a point halfway along that curve, right? As well, we divided a curve. And so let's say we divide a curve 10 times. We'll get 10 divisions. Each of those divisions will be populated with a point. And so we get 11 points, starting at 0 and ending at 1, right? Also with dividing curve, we populated those with perpendicular planes, the sort of normals to the curve. And so again, just a friendly reminder about what we were doing with curves, because we're going to do this similar thing with surfaces. But surfaces are fundamentally different than curves, geometrically and topologically. You can move in two directions at once on a surface, whereas in a curve, you can only go one direction, forwards or backwards, right? Okay. Here we can go in what we call U direction and also in a V direction at the same time. And so if we think about U and a V being a sort of latitude and longitude address that creates basically a grid along our surface, right? Our starting point on the surface might be U0, V0, right? And as we move this direction, U approaches 1. Okay, if we move this direction, V approaches 1. And of course, when we get to the opposite alternating vertex of the surface, U equals 1 and V equals 1, okay? And so if we wanted to, let's say, evaluate the surface at a UV parameter, we would plug in first a coordinate in U, right, 0.5, and then also in V, 0.5. And so we get a point somewhere towards the middle of our surface, right? And so if we think about V, 0.5 being a sort of latitude or a longitude line, and U, 0.5 being a latitude line, right? Where those two things cross, we'll get the U 0.5, V 0.5 point along the surface. Okay, and so that's how we can start to map locations and points on a surface by giving it both a U and a V. And we can basically locate any position on the surface. Okay. Likewise, if we start to think about multiple latitudes and longitudes, right? So we have, let's say, U 0.5. This should be, let's say, maybe U point. Let me just double check, change this really quickly, of course. Small typo here. So if we go, let's say U 0.4, U 0.5, right? We can actually define a strip between that 0.4 and that 0.5 along the surface. And if we do the same thing in V, right, then we can actually locate a sort of checker region, right, some sort of four-sided polygon along our surface, a subsurface, a subset of our surface, so to say, right? So if we said, basically I want just a piece of the surface between 0.4, 0.5 in the U and 0.5, 0.6 in the V, this is what we would get. We'd get this little piece of the surface right here, okay? So try to keep this in mind. I can refer back to this when we get to these relevant parts for the next set of surface widgets I'm going to show you in Grasshopper. So let's go ahead and move to Grasshopper right now. And I'll move to Surface 01. Okay, these are example files I'll zip and provide you on the website. Excuse me, sorry. But basically, I've also annotated these with comments. So you can see here, I have 3 curves drawn in Rhino. I'll turn Grasshopper off. 3 curves drawn in Rhino that I've referenced into Grasshopper, do the curve widget, right? So In this case, I right-click Set Multiple Curves, and then select all 3 curves at once. Okay. And I've plugged those into a loft widget. So this loft widget lofts any curves that I plug in into a surface. Okay. And that's basically the summary of what these notes that I've written for you in Notepads say. I'll go to Surface 02. Okay, this is a friendly reminder. Okay, to be very careful when you're actually selecting the curves. Okay, and so if I turn this off, right, if I want to loft between this curve to this curve to this curve, that would make a lot of sense, right? But unfortunately, what I did here is I selected them out of order. So I said select multiple curves, and I selected, select multiple curves. I selected this one, and then this one, and then this one. And so, aha, look what it did. It drew a surface lofting between this curve to this curve and then back to this curve. So it sort of folds over itself. So again, just a friendly reminder to be very careful about selecting the curves in the order that you want them to actually, you want the loft command to actually use them in, right? So this is a mistake I see a lot. So this is just a reminder to you. Quickly talk about that. Surface 03. All right. And so here we are evaluating our surface at a UV parameter. Okay. So here are our curves that I've referenced in from Rhino, and I've passed those to a loft widget. Okay. And so the result of this widget is a lofted surface, which turns green when we select the widget. And so here I'm just going to zoom in just a little bit, try to enlarge this, and so I can make this a little larger. Okay. So you can sort of see the note as we talk. Okay. And so here's the evaluate widget. It needs the surface to evaluate. You'll also note that I've reparameterized the surface by right-clicking on this input and selecting reparameterize. That ensures that as I move from U to the U minimum to U maximum, the V minimum, V maximum, that those minimum maximums are set to 0 to 1 and 0 to 1. Okay. And then I can plug in a multidimensional slider, number slider. Okay. Ta-da. Now you'll notice that, you know, we're basically telling it a location, a UV location or coordinate on the surface. What it does is it passes us, first of all, it creates a point at that location for us. Okay. So that point shows up as a little X. It also shows the normal direction for us. And I've made sure that we can see that normal direction by drawing a line in that direction from our point. Okay, so you can see that this line is going to be perpendicular to the surface curvature. And so you can begin to see that as the curvature of our surface changes, so does that normal. That normal changes its direction, right? So sort of perpendicular to the surface at our UV coordinate. It also gives us what it's called a frame, but that is basically a plane. And this plane is perpendicular to our normal, right? It's basically taking the tangent in U and the tangent in V and creating a plane from that information. So it's sort of the tangential plane, if you will, for the surface. And again, that also changes its orientation as we move around the surface because every discrete location on the surface has a slightly different curvature to it. Okay. All right, so that's that one. And again, I've noted this for you. So again, we get out a point, a normal direction, and then the tangent plane when we evaluate the surface at a UV parameter. And last but not least, here's 05. Oh wait, sorry, I skipped one. 04. So we're not done yet. Okay, here, what we're doing is, let's see if I can get this to show up a little better in the preview. We are giving it a minimum and a maximum longitude, a minimum maximum latitude. And so we're doing just what I was showing when I had Illustrator opened up just a minute ago here, right? So I'm giving it a minimum and maximum in the U and a minimum and maximum in the V. And what it's doing is it's plotting these out and defining a region of the surface and basically pulling that out as its own smaller subsurface, okay? And so let's take a look at this widget. First of all, it's called isotrim. So what it does is it extracts an isoparametric subset of a surface. That's a lot of big words. But essentially, let's look at what it's doing. First of all, we're lofting the three curves into our surface, and we're plugging that surface in, and we're reparametrizing the surface. But then what does it ask us for? It asks us for two different domains, right? A domain in the U, a minimum maximum in the U, and a minimum maximum in the V. And so this is just a widget that lets us construct a two-dimensional domain with a minimum U, minimum V, maximum V, which I've plugged in sliders for. And so you can see, I'll go ahead and select this. So you can see highlighted in green the portion of the larger surface that we're pulling out as its own smaller surface, right? So here it spits out this smaller surface for us. And I can redefine that by where that surface starts and ends in both directions by changing these sliders. Okay, and so we're pulling out just a portion of this surface, okay, as its own. So if I baked this into Rhino, okay, right, and I close Grasshopper and I turn on my shaded viewport, you can see that we just have that part of the surface now that we pulled out, right? Minimum U, minimum V, maximum V. Okay, that's really, really handy. What we'll be doing in some later examples is we'll be dividing the surface up into lots of little checkers in this larger checkerboard of a surface. Okay, and so if you think about this, maybe almost think of it as a sort of Excel spreadsheet, right, with columns and rows, right? We'll divide this up into cells using this command, okay? And then we'll populate each of those cells with a parametric component, some sort of differentiated component that you'll be creating for project 2, okay? So that's kind of where we're going with this. I know it's a little abstract. We're going to practice this quite a bit. I'm going to build on this as well with some more demonstrations here coming up. All right. I'll see you soon.